welcome to today's webinar brought to you by Cleamix. Last week we had a tremendous show here and the following was spectacular. I think we got over 70 unique followers for our show, and we thought that it would be awesome to do another one and go a bit more deeply on the subjects at hand. On today's webinar we're going to focus on three particular subjects. The first one is going to be decontamination of disposable medical gear. The second one is going to be reducing risk of airborne COVID-19 exposures. And lastly, on the third point, we're going to go through Cleamix practical use cases for that time. Could I please see the next slide? So to go through the agenda for today, for everyone involved and present there at the webinar, first Panu Vilska, the CEO of Cleamix, will start to have a keynote presentation on what can be done to ensure critical supplies don't run out. Then we can gonna progress to principles and practices of decontaminating and reusing disposable protective gear. After that, we're gonna have a panel discussion with our panelists and a Q&A session with questions gathered from the website. And we strongly recommend that all of you involved send us questions via the question box at the right center or the right corner of the webinar page. After the first panel discussion and QA, we're going to progress to talk about corona spreading as an aerosol. We can also have a panel discussion regarding that one and a Q&A session. And lastly, at the end of the show, we're going to go through the use cases in detail. We're going to cover ambulances, hospital rooms, aircraft, and other equipment where Cleamix has been and is relevant. And at the end, we're going to have a summary and the key points to take home from this show. But before I give floor to Panu, I'd like to introduce our upcoming speakers. The list is following. We are going to have Emma Nykyri, the training manager of Cleamix, joining Panu for the rest of the presentation. Hailing from Korea, we have Professor Dr. Yang, the principal researcher, member of Science and Technology Advisory Committee. Then we're going to have POLRI Dr. Janne Kuusela from the South Savo Social and Health Care Authority. Then Alexander Aminov, FinProtect, the main partner of Cleamix, and also Stefano Fiorina, DASP, Cleamix partner company. Really happy that everyone is involved in this panel, and hopefully you'll all have a great time at this webinar. Well, without further ado, I'll give the floor to Panu here.
Thank you very much, Tuomas. So welcome to the webinar on my behalf as well. And we are doing this now for a second time with a slightly adjusted topic. This is due to the request from our partners. We did last time this in Finnish, and now this we are conducting in English with a little bit different and more tailored focus. So as we know, corona outbreak, it has caught the world totally unprepared. And what used to be, or what some people say that it's a Chinese problem or Asian problem, it really turned out to be a global problem. Nobody is safe, nobody is isolated. And no matter how well prepared, there is chronic shortage of essential medical gear everywhere. And it's not much use to have a state-of-the-art high-tech emergency facilities and intensive care departments if you don't have the basic gear that you need, which means masks, gloves, aprons, protective coveralls, and all those disposable items that everybody takes for granted. But now, when we have a pandemic, all those supplies are running in short supply, and even countries which have well prepared for emergencies, like Finland, for example, we are facing shortages of those consumables. So we have come to the point where we have to also think out of the box. If something is in short supply, then we have to be creative on how, when, and on what conditions it can be recycled. So one of the items which has been in most, let's say, critical shortage globally has been the breath masks, both the surgical masks and the N95 FPP2 and 3 level masks. So those disposable items, Finland alone, for example, consumes them maybe 2 million, 3 million a day. That's the figure I've seen in public discussions. And reusing them is, under normal circumstances, not really even considered. They are disposable items. They normally cost anything from a few cents to maybe 20 cents a piece. But now, when there is demand more than production, especially for the certified validated qualities, we are facing a situation where a single N95 type mask can cost $1.5, $2.5. So in those situations, it's not just about money, it's also about the availability. How many of those you have, and if you just dispose of everything, you may actually have a situation that you run out of them. So what can be done? So hydrogen peroxide vapor has been successfully tested already years ago for reuse of disposable masks. So there is one study conducted by CDC, and more recently there was another study by Duke University where they analyzed what kind of methods, what kind of dosages are required to safely recycle a medical mask. Now, of course, common sense should be applied. If the mask is clearly dirty, there's blood or other visible dirt, makes less sense to recycle it. But for example, if the mask has just been used by a nurse that quickly visits a elderly care home room and leaves the room right away, so there's no reason to dump that mask after single use. It could be done. It could be thrown into recyclable box for further processing. In some of the earlier tests, it was concluded that with condensing hydrogen peroxide system, it took up to 480 minutes. How much is that? Is it 8 hours, 6 hours, 8 hours, something like that, for a 6-log kill, which means the full kill on the target. Now, more recent studies by Duke University, they suggest that 480 or more ppm for 45 minutes is sufficient. We don't have exact information, but I think, actually there was information. It was a condensing system, so it wasn't dry. It wasn't a dry method, so it was a condensing system used. So anyway, if we look at the process of how to recycle the disposables, so we are looking at the same simplified process flow as we had last time. Could you please change the slide? Thank you. So first of all, if it's not paper or fabric, if it's like a plastic or something that you can wash, then in that case you wash it. But of course, if it's like a paper mask, you don't wash it. You just make sure that it's visibly clean enough to justify the recycling. Then by our experiments, the exposure to hydrogen peroxide vapor should be at 600 ppm or even more. And with those concentrations, and we are getting easily 6-log result in 15 to 20 minutes. So how is that done? So the objects, textiles, I mean, it doesn't have to be masks. It can be coveralls, it can be aprons, anything you want to recycle. You just hung them loosely in a treatment cabinet or room, and after that they are exposed to high concentration of hydrogen peroxide vapor. And in our testing, as said, it's about 15 to 20 minutes. So if we look at the alternatives, I'm borrowing a slide from VTT here now, the one that we also saw last week. If an autoclave is used, if alcohol is used for masks, it simply causes too much degradation to filtration efficiency. So it means that you can't really wash them. Now, other methods are also applicable, but the hydrogen peroxide is pretty much the only one that leaves no residuals inside. So ethylene oxide, different bleachings have been tried, but then you have the problem of the aftermath. How do you do after that? And even microwave oven is not really a good idea, because many of these disposables have plastic parts and they can melt. There's always enough humidity that you can melt the plastic parts of this equipment. So let's look at our own experiments. So we have together with VTT, which is the National Research Center of Finland, the first test run of which we saw some results in our previous webinar. The first test was done in low concentration. Low concentration means 300 ppm, and the relative humidity when we started the treatment was 25%, which is very typical for Finnish winter weather. 25 RH is extremely dry. So in those conditions, we got visible change in chemical indicators in about 60 minutes, and something which can be safely considered to be 6-log kill, it happened sometime between 60 and 120 minutes, so between 1 and 2 hours. So that was the initial benchmark test in dry air, low concentration. Now after that, another test was done, and this time we manipulated the conditions a little bit to our benefit, because as we discussed last time, our hydrogen peroxide generator is extremely efficient, so the relative humidity and relative saturation don't increase that much. So of course when you get hydrogen peroxide in the chamber, the relative saturation rises, but the humidity pretty much stays at the same level. So the other test was done with the higher relative humidity. So we actually didn't artificially raise it, but we put the target to 600 ppm in this case. Emma, do you remember the size of the VTT test chamber? I think it's about 30 cubic meters or 35 cubic meters.
Yes, around that.
Around that, yes. So this time when we had a higher concentration, we got the relative saturation up to 74%. So now we saw visible results in 15 minutes. And we can say that the 6-log confirmed kill happened at 30 minutes. And we could further decrease this time needed by further raising the humidity in the chamber. So I'm not talking about condensing it, I'm just talking about having a combination of higher temperature and higher total saturation to accelerate the process. And what we have seen in our earlier testing is that we got the Thermophilus bacteria, the C. difficile, the typical anthrax substitute, we got it killed in 15 minutes or even less. Some results were even in 12 minutes. We got it killed in a 10 cubic meter test chamber, and that 11-12 minutes includes the 5 minutes that our machine is using for initial heat up before it even produces vapor. So this simple experiment showed that we can get to 6-log confirmed kill in 30 minutes or less, instead of 45 minutes, 1 hour, or using 8 hours for the process that it has been done before. And of course further testing is required, further testing is needed, but this shows in our opinion that this is feasible method and worth further studying. I know authorities in Finland and in many other countries, they don't like this idea because they say there's too much risk involved. I do agree, there is risk involved. However, if your options are running out of material, it's better to do this than simply be without anything. And in US, CDC has approved this method. So if you fight the war, you use the weapons you have. So how do you do it in practice? So how do you make an ad hoc decontamination chamber or a permanent decontamination chamber? You can use any airtight space, any room. You can make it from sheet plastic. So here we have examples. On the lower left corner, we have the same picture you saw in the last webinar, which is at the Finnish military base. Their ad hoc chamber, which they just made of sheet plastic. On the right-hand side on this slide, you will see a special-made decontamination container, which is actually made to our design. The manufacturer is Intlog, one of our partners. And there you can see that you have all the equipment and gear which helps you to put the object loosely enough so that there is proper airflow. You have space for the hydrogen peroxide generator. You can put material on hangers. You can put them on like a bags that let air flow through. What is essential in this arrangement is very essential that you have proper airflow, and the proper airflow is achieved by using just normal fans, so normal freestanding oscillating fans. We haven't yet tested how many masks can be fitted into one container for treatment, but I can assure you that it's a very high figure. And our vapor generator is enough, more than enough, that one unit can deal with a very high number of material in a reasonable time. So that's just one example how it's done. So these chambers can be located at every location where you have shortage or even speculated shortage of material. And if you think, for example, protective coveralls, they don't get dirty like the masks that get dirty. So it makes a lot of economical sense to circulate them. I've seen those coveralls costing 15 to 20 euros a piece, and they are disposed after single use. I think that's not just waste, but it's waste of money and resources. Okay, the next slide, which is last on this topic, it shows the Duke University test arrangement. So they placed masks on shelves. They had the hydrogen peroxide generator outside, and they ensured proper airflow. And that's the simplified method or simplified diagram of their experiments, which is actually exactly the same as we do. The only difference is that in their test, the machine is outside, and in our test, the actual vapor generator is inside. Of course, if they use a machine which is the size of your fridge or van, they don't have other option. But in our case, when it's a small briefcase doing the same job, you can actually easily have it in the same space, and you don't have to do any penetrations for piping or such. So that concludes our part of disposable equipment recycling, and I'm sure we have a lot of questions on that. But now I will use the opportunity to introduce Emma. She wasn't yet visible on when we started. So Emma is Cleamix training manager, and many of our partners recognize her from the video trainings that she's been doing for partners near and far, as we can't travel for on-site training. Normally we do all the training hands-on, but now it's not possible. So welcome, Emma, joining here today.
Thank you.
So what have you seen there? Have you gotten a lot of questions about the feasibility of recycling like masks or coveralls?
Yes, a lot actually, because it's a very hot topic right now. Everyone is dealing with the same problem currently.
So is it more of question of facilities not having money to buy equipment, or just sheer availability?
There isn't availability for the equipment.
That's sad. So what about the situation in Italy? How are you doing there? Do we have Italy online? No, we don't. So let's try. Do we have Korea online, Professor?
Mm-hmm.
So what's your opinion on recycling masks and other critical equipment when there is shortage of supply or supplies are running low?
My opinion is very agree your trial, and also that in Korea, our government recommend that the probably 2 masks per 1 week will be fine. That means 3 days or 4 days using the one mask. But we didn't recommend that reuse. But the personally or the individual case that have to use one mask for 3 days means that have to control that the decontam, or some guys try to using the microwave, but that microwave could uh, depict that the textile, so that's not a good way. And I think uh, the VHP, yeah, should, should very helpful to make reusable, protective gears.
Alexander, did we have okay? We have Stefano online from Italy. Did you what do you see in your home country? If have you had any discussion about need of recycling masks and other normally disposable gear, or what do people think about the idea if supplies are simply running low?
Good morning, Panu. Good morning to everybody in the webinar. But let's say that in Italy, in this moment, there is still a lot of confusion about the use of recycling, mask. There is the need, I think, to prove that this kind of treatment can be really helpful to avoid any kind of risk. So in this moment, we have a lot of needs to prove this kind of approach, let's say.
Thank you. And as I mentioned, I think same common sense should be applied. For example, you can't recycle a broken bottle. So if you have a mask which is visibly dirty or there's blood or whatever, that should be disposed. But if it visually seems to be okay, then recycling could be considered. Thank you. Okay, so we have next topic is what we have called airborne threat, and unfortunately we just got information that our panelist, who is a specialist on this topic, cannot join. He's in a emergency meeting, so I'm trying to cover the topic the best I can. So there has been initially, first of all, authorities said that coronavirus only spreads as a droplets, or 1 meter is sufficient safety distance, or 2 meters later on. However, there was sufficient doubt in the scientific and medical community, and there were those who actually said that it seems that the coronaviruses, they actually spread like aerosols. They can spread airborne over long distances. And there has been a lot of research on that. And on the next slide, we have this is actually a screen capture of a Chinese study which was testing survivability of coronavirus on different surfaces. The links. Oh, by the way, all these links and presentation will be downloadable later on, so you can check those articles in detail yourself. But what was surprising to many experts, even, it was surprising how long the coronavirus actually survives in the air and on the surfaces. And one of the extremes was that up to 17 days after passengers had disembarked, there was still traces of coronavirus found on the Diamond Princess cruise ship. So that establishes quite sufficient doubt on the claims that it A, wouldn't be airborne, and B, wouldn't survive on surfaces. Now here in Finland there was a research by Aalto University, and they made a supercomputer model. It was actually in newspapers yesterday and day before yesterday. There was a quite broad article on that. We will add this link to the materials as well. And that showed clearly that the distance that coronavirus can travel, it's actually unlimited in some sense. And it was also established that it lands on surfaces. So from the air, it sticks to surfaces. So when you go to grocery store or you go to just public places, it is a good idea to wear a mask. Of course, my personal opinion, but I think it's based on many expert opinion as well. So you expose yourself every time you go into same room with other people. And that's why it's recommended that don't go to public spaces at crowds. Try to minimize your shopping. Don't go every person in the family shopping. It's enough that one person goes in, because it really spreads and it sticks to surfaces. So we are fighting a pretty nasty enemy here. And now if we look at on the next slide, we have this pathogen resistance against hydrogen peroxide vapor. And there we see the good news. And the good news is that enveloped viruses are easiest to kill with hydrogen peroxide vapor. The ones which are hardest to kill are bacterial spores. Now the good news is that, for example, the standard testing of biocidal efficiency of hydrogen peroxide vapor is done against bacterial spores. So when we get results of those, we can be quite sure that also applies to viruses. Okay, somebody will ask me, of course, that what about, have you tested on real corona, and how much you have been testing with real corona? The answer is that actually we haven't. We have tested with a multitude of different viruses, but we haven't yet run testing with confirmed corona. So this is something we are still working closely with VTT, and this is actually open request to the medical community in Finland. If you can provide us a good sample of corona that we can test against, we are more than happy to do that with VTT as soon as possible, or we can do it in any hospital laboratory. But anyway, the good news is that it's not among the most difficult targets. So what can be done? So now this comes back to the main reasoning why we are saying that Cleamix can help with the corona outbreak containment, and what can be done is, as it's an airborne threat, it sticks to the surfaces. It makes a lot of sense for frequently decontaminating interior spaces. Now I'm talking about hospital rooms, I'm talking about offices, meeting rooms, especially public transport, buses, trains, taxis, and then for those who work in this field, ambulances, police cars, and so forth. So it's relatively easy, painless method of making sure that you don't get excess exposure from airborne particles that actually stick to objects in the rooms. Now, our medical expert, who was unfortunately not able to join today, he used an example that in storages of hospital, for example, storage of certain in-vein, I don't remember the English word for it, but cannules, I think cannule is the cannule storages. somebody goes in there with corona and touches, like there's a candles, there's a masks and other medical gear, and after that, if they are not individually packed everything, that whole room is contaminated. Everything in that room is contaminated. So it has to be decontaminated. Okay, how to do that? I don't know any other feasible option than hydrogen peroxide vapor, because if nothing has been moved around there, then you only have the exposed surfaces still exposed, and they are equally exposed to hydrogen peroxide vapor. So that's how you can save the day, and you don't have to clean or dispose of everything that was in that room. So that is just another example. So I don't know if we have questions from audience about this airborne corona distribution, but Professor Young, what do you think about? What does the Korean scientific community think about spread of corona? Have you been seeing discussions about like a long-term survivability in the air or long-distance transport of the viruses by air?
Yeah, it's probably the day, yesterday or the day before yesterday, we have good evidence for airborne transmission of COVID-19 virus. Our colleague, he worked at the Chungbuk National University Medical Center. He tested with the COVID-19 virus with pellet, the small animals, and then the result clearly show up that it's a possibly airborne transmission to the healthy pellet from the native pellets. So that the transmission is not only by the compound the patient, people sudden symptoms, still they have the possibility to transmission of the virus is likely airborne transmission. So our peoples nowadays is mainly agree with that the airborne transmission possibility in Korea.
Okay, we have questions from audience on this topic. Alexander, do you have them, or Tuomas? Who has the audience questions on this topic? Alexander, please.
Yeah, I have them. There's a question from Petri. You are mixing mechanism, droplets flying up to 2 meters distance, not through airborne transmissions, versus true airborne transmissions, as for measles, smallpox and tuberculosis. There is no true evidence of aerosol transmission so far for coronavirus apart from example ICUs performing aerosol producing procedures. Modeling does not prove that this as a fact. It may suggest mechanisms which need evidence from more concrete setups.
Yeah, I mean that's.
Could you elaborate a bit more those tests?
Yeah, that's a good statement, or I would say obviously that whoever Petri, thanks Petri for the comment. It just shows that the expert community is not completely in agreement on which way this fact is, or whether it's a fact or speculation. Now, as I said, we refer to the modeling that university researchers have been doing, but I think there is sufficient probability that this is the case, which means that the precautions which are taken in hospitals and precautions that governments should advise people in their everyday behavior, they should take to attention this very high probability that there is a severe risk of airborne contamination, airborne infection. So I think that if something can't be proven 100%, that doesn't mean that the risk isn't likely or possible. Alexander, actually,
Yes.
yeah, any other comments on that?
Yeah, there is a question
Professor,
from.
Sorry, Professor, Professor Young, did you have a comment on that?
Actually, the 2 meter distance, likely the safe distance is not the scientific. Just we guess that the distance will be fine. At times they concern about this, just the droplet, but nowadays we didn't expect that that rapidly spread all around the world. That means that that virus, the survivor at the air condition is very longer than we expect. They say that the 5 or 7 hour will be that the virus will be destroyed, but not likely that. And also that our people is a more precautionary that using that the mask tightly. So then the mask probably keep safely to protect transmission human to human or even the airborne transmission. That's why I think it's the good strategy to control that the air or the space decontaminations with VHP or other method could be help to that protect spread out from one one patient to that public.
Thank you. Alexander, we had more questions, I think.
Yes, Sean is asking how to detect equipment which cannot be decontaminated. Example, clothes which are too humid.
Oh, that's a good one. That's actually a very good one. So we earlier in some of our studies we concluded that it's not feasible or not good idea to try to decontaminate wet objects. So for example, if you have let's compare it to like laundry straight out of laundry machine, it's moist and wet. So before you could actually decontaminate that with hydrogen peroxide vapor, it should be dried. So I think, Emma, you have been dealing a lot with decontaminating items or objects. So I think it was in your own checklist that individual items or clothes which are being decontaminated should be dry. Isn't that the case?
Yes, that's the case. It should be dry because otherwise there will be the condensation problem and
condensation problem, but wasn't the other reason that if the cloth is wet, the vapor doesn't penetrate into the fabric because it's full of water, right?
Yes, that's also.
Yes. So I guess the answer to Sean's question is that objects which are being decontaminated, they should be dry or near dry.
Then should we continue on this question? Do you consider it better to decontaminate first and clean them, laundry them after that?
Another good question. So I guess it's a little bit case specific. Masks, for example, the initial conclusion was that it doesn't make any sense to wash masks with any liquid because that will seriously degrade their filtering efficiency. But if we talk about let's say reusable clothes like the outfit of hospital staff, I'm not talking about disposables now, I'm talking about regular clothing. The benefit of decontaminating first with vapor is of course that then it's much safer to handle them in laundry machines. And on the other hand, what we have been told by hospital cleaning staff is that if you want to be sure that no microbes are left, you have to wash them at a very high temperature, and even that doesn't ensure that everything is dead. So I think the take there is that if you have to choose, I would do the vapor treatment first and then send them to the laundry. But okay, so one more addition. If it would be about treating common mold, which is a typical problem in problem with apartments and houses, that in that case it would be more like vice versa: wash first, then dry, decontaminate. But now when we are talking about viruses and bacteria, I would do the vapor treatment first. Alex, any other on this topic?
Yeah, we can. Yeah, could we go there then to more technical questions? Would it be true to say that one of the advantages of Cleamix is that it reduces the effect of corrosion on treated surfaces and materials by eliminating surface condensation?
Okay, I think that goes a little bit off the target. So there may be maybe some misunderstanding on certain principles. So if we compare different decontamination methods, our approach is what we can call dry. So there is least amount of micro condensation or any moist on the surfaces being treated. So yes, the risk of corrosion because of the treatment is minimal or non-existent in our case, but it doesn't protect the equipment as such. So I think the question probably was referring to that: are there differences in corrosion risk between different methods? And I would say that our method is the least possible risk for any sort of corrosion to occur during the process. But I think whoever made the question, he's welcome to broaden it, and we can return the answer later in this broadcast. Let's take one more and then move on with the agenda, and then we can take
actually
the rest.
we have one comment and one question from Yahia. So the question is that using H2O2 should be carefully considered. Is not too much humidity preventing efficiency for HPV decontamination? And the comment is that agree with the statements to consider this virus an airborne transmitted until proven not. The cost of these precautionary measures is far less than treating a corona patient.
Yeah, that's obviously so. So it's like in any process, the more you do planning, the more you do precautions, the more you have damage afterwards. And it also applies in healthcare. The more you prepare, the more you have surprises afterwards. Okay, so next on our agenda, we are revisiting some of the use cases and best practices regarding the use of hydrogen peroxide vapor. So Emma is here also for the reason that she has been doing those field operations more than I have, and she has also seen all sorts of conditions and situations, and she's very good in what we use the term dimensioning the target. So what kind of machinery, how much, how long is needed for each different objects. So we are now revisiting the ambulance cases. We did few more of those, as well as the hospital room, and also some generic use cases. So let's first take a little reminder on this humidity and condensation part. So just for those who didn't participate last time, I'm borrowing one slide from our partner Vaisala Corporation. As you know, we are using their sensor technology to make sure that we don't condense on the surfaces. But Emma, can you please explain again why it's important to understand this saturation versus humidity issue?
Yes, it is very important to understand the difference between these two parameters and how does those affect to the decontamination process. Well, if we look for the paragraph there on the picture, there is the second one where you can see or in the picture you can see the difference between the this relative saturation and relative humidity. So in relative saturation we have there the water vapor and the hydrogen peroxide vapor together in the air, and that is the critical parameter that we want to look during the process, so that we can make sure we don't hit the condensation point. These parameters are very important to look also before the decontamination process. So when we are planning the decontamination treatment for the facility, it is very important to take a very good notice with these parameters and also with temperature, because it is affecting quite a lot to the outcome of the decontamination process.
Yeah, that's true. I think we referred also last time to some of the CDC studies which showed that increase in humidity can tenfold the biocidal efficiency of the process, but of course it increases the condensation, and the more you have condensation, the longer aeration or ventilation time you need. So this is all careful balancing, and it's then called user experience, what helps you to optimize the outcome and the process. Okay, so the use case we briefly visited last time was the decontamination of a biosafety 3-level laboratory. That was in Korea. Their main health authorities research laboratory, biosafety classes 3 and 2, and that was done in second week of February, 2,500 cubic meters in 2 floors, and we were given restrictions that only during normal business hours. And we had 4 of our devices available for the process, and in addition to that we had 2 catalytic converters for removing the hydrogen peroxide after treatment, and of course lots of oscillating fans to help distributing the vapor evenly. So in that case we segmented the area first. So we divided on the day 1 we treated the BSL2 lab, and that one we segmented in 3 different volumes to ensure that we have sufficient vapor output capacity. We located the machines there evenly. There were large corridor areas as well as individual rooms, and after the first day, it was concluded that it was not necessary to have 3 different segments. On the next day, we did the BSL-3 area in 2 segments, and we found out that it was enough. It was enough to have 1 hour 15-minute treatment at full output power. We were initially expecting that we would need at least 1.5 hours, maybe 2 hours, but laboratories, they are made mostly of inert materials, metal, plastic, glass, non-reactive furniture, or furniture which is quite inert to chemicals. So we used the experience we had from our laboratory tests, which showed that when we have a chemical indicator color change visible, we wait 10 more minutes, and we never failed a 6-log biological confirmation when we followed that rule, and it applied here as well. Now, the other good or benefit of cleaning a laboratory is that they have extremely powerful ventilation system. So it was about 30 minutes after shutting off the treatment cycle that the ventilation system had made the area accessible again. And it was also quite obvious that the ventilation was so effective that we saw no difference whether the catalytic converter was even there or not. So that was a good example of place where just the normal air system is enough. Now we did the case in 2 work days, and we were not allowed to do any preparations prior arriving to the site, so we had a lot of hassle during the first day when setting up everything. And we estimated that with some better planning, with same equipment, we could do the work in 1 day. Their earlier technology, or they actually used a contractor there who used condensating HPV technology, so machines that produce heavy surface condensation. And even with that approach, the requirement was 4 days. So 24 hours a day, 4 days to have this whole area treated. So this was a significant improvement compared to what they had before. Okay, so then another example, which is very typical, is treating an ambulance. And there was a case here in Finland where there was a confirmed corona patient, but it was suspected from the beginning that the ambulance was carrying a corona patient, and due to some unfortunate circumstances, the patient was quite long in the ambulance, so it was considered heavily contaminated after transporting. And we did 2 different cycles there, or 2 different decontamination sessions. The first one was the initial, which was also training the hospital district staff, and then next week we had another session. Emma was there training them, like having a more extended training for additional team members. And on the first time we had a cold vehicle that had been out and it was like a freezing cold when we took into the garage, and the second time it was prepared according to instructions. But I will let Emma to explain how was the treatment. By the way, we still have one funny Finnish word there, 1.5 deciliters of liquid. The liuosta is Finnish and means liquid. We will update that to the presentation when it comes for download.
Yes.
Emma, please.
Okay. So on the second round, when we were having the training sessions and we made this decontamination for the ambulance, we prepared the decontamination process by warming up the ambulance. It came from outside and it was freezing cold when we took it inside to the hall or the carriage. And then we warmed it up between 5 to 10 minutes with this warm air air blower that is blowing warm air inside to the ambulance. And with that we got this temperature inside the ambulance up to 25 degrees. And when we started the decontamination process, we got the temperature raising up to 26 degrees. And it was very good temperature for the process, because we got to see that we got in less than 10 minutes over 200 ppms to the ambulance, and we got very efficient and fast treatment made for the ambulance. And after 50 minutes or around 1 hour, we had the car back in driving and back in business.
Yeah, that's quite amazing, because when we had a car with cold structures, it took us 45 minutes to see indicator tape color change, and we ran to 60 minutes. I think you mentioned to me that you saw the tapes changing colors already at 20 minutes. Was it so?
Yes, it was around 20 to 30 minutes actually.
Yeah, okay.
Yeah.
But in less than an hour, the car was back on the road.
Yes.
That's pretty good.
Yes.
There's actually right now a bidding in UK about treating ambulances, and their benchmark is that their current process takes 45 minutes. But there was no indication on what is the requirement there. Is it 6-log kill or what? I mean, they didn't really tell what are they doing for the 45 minutes. Now we do know that if they are using aerosol sprayers, it's actually even worse than just wiping it, because as we know from the testing we've done before, that the aerosol sprayers have absolutely no effect on any biological indicators that are normally used to confirm the result.
Yes. And when we look for ambulance as a facility, there is lots of air pockets, and there is lots of it is quite a difficult space because it is not inert. There's lots of
exactly
differences.
And you have, and I guess in both cases we opened all the hatches to expose
yes.
everything inside the ambulance. Okay, so the second example is a hotel. Oh, by the way, before we go to the hotel room example, the ambulance that had in both cases power plug inside, correct?
Yes.
And we could seal it completely. And car, like ambulance, is pretty easy for a decontamination point of view because it's airtight. It's sufficiently airtight. We have seen some ambulances, for example, in Korea, where they have big ventilation hatches on the roof, which have to be physically sealed. Because
yes.
Otherwise, if you do it in a garage, you will soon have this distinctive smell of hydrogen peroxide around.
Yes.
Okay, so let's go to the next use case, which is the hospital room, and this is the good old example from Jakarta, and isolation room in a Ministry of Interior's hospital. Conditions were quite challenging, so the relative humidity, even though they had some level of air conditioning there, the relative humidity was 70%. And if you look at the user's guide of any of the alternative hydrogen peroxide technology providers, they require drying the air to at least RH 50 or less before starting the process. Well, of course, if you mostly produce water vapor, it can be a serious problem from condensation point of view. Now, in this case, we got the 6-log result in 45 minutes. So we actually got the color change of indicators in about 30 minutes. And after that, the ventilation took another 30 minutes. So this was the fastest process that we have ever seen in a room of that volume. And I don't know if the temperature, humidity, whatever made it, probably combination was for the fast effect. But what was even more surprising was the very fast aeration. Now, in this particular case, we couldn't completely shut off the ventilation system, but nevertheless, we got pretty good result. And the RS was at max point, it was 86%. So now we are talking about the combined humidity of hydrogen peroxide and water. And so we were still far away from condensation point. And like many hospital isolation rooms, this one had a window, so we could observe the indicators in real time. So this was a very good use case and training example for the customer. Now, if we think about process in a typical hospital room, what is extremely important is to make sure that you don't have leaks. And that means that taping the door tight, making sure that the ventilation shaft is shut off. And why this makes a lot of sense to use in hospitals. So this corona outbreak shows it very clearly. If a patient has been in a room and taken, for example, to intensive care, the room needs to be decontaminated before next patient is brought in, unless that patient is also a corona patient. But let's suppose that you don't know, it's better to treat the room. And frequent decontamination, or if it's a kind of standard practice between patients coming to the same room, then you ensure that you don't have this problem of corona surviving on surfaces or surviving in the ambient air. And if we think about nursing homes, it's not actually a big trouble to go room by room, make sure that there is frequent decontamination of the living areas, living quarters, individual bedrooms, in addition to using masks and other preventive measures and methods. This adds a level of safety and confidence and reduces the risk. Now, showing also here the innovation or innovative approach from our army. They made this decontamination chamber out of sheet plastic. So if you don't have an airtight room for the purpose, if you don't have a container that you can use, all you need is some sheet plastic, and you can make your ad hoc decontamination chamber that you can use for treating objects, equipment, clothing, whatever, or disposable masks, who knows. So about these use cases, I think we got a lot of questions. So one thing I think, Emma, about the procedure, when we prepare a hospital room, for example, can you describe the steps? Let's say that you come to site, you have the equipment, and they show you that this patient room needs to be decontaminated. Can you just run through what's your process? What do you do? You have the equipment there. What's your next step?
First, I will make sure there is no plants or food or these things that should be took off from the facility. Well, if we look for the hospital room, many cases there isn't any of those things. Then I will look for the ventilation. How is the ventilation there, or some possible gaps or things that should be sealed, so that we can make that exact room a gas tight and sealed facility. Then when we make the setup of the device and the fans, we at the same step we think about the air circulation, because that is very critical part of the decontamination process, and how is the outcome, because we need to get the gas everywhere. Then we look for the parameters and the what is the situation in the facility and in the air in that space at the moment. What is the temperature? How is the humidity there? And so that we can make plan for the decontamination process made well enough, so that we will have the ideal outcome of the decontamination process.
Now, in Finland we have typically very dry air. What sort of ppm target you are using in a typical hospital room? Winter, let's say winter time, we have that very dry air conditions. So what's your recommendation for a frequent, like a periodical decontamination?
For my recommendation would be around 250 and 300 ppm.
For how long?
Of course, it depends of the size of the room and what kind of materials there are. Well, a hospital room is usually very inert. I would say 1 hour is well, because 1 hour is a good time for that we can be sure that the gas is gone everywhere.
And from chemical indicator tapes, you know anyway when the
yes.
But I think many people have been asking me that what's your standard parameter. And for example, in this laboratory case, we estimated 1.5 hours, and it turned out to be 1 hour 15 minutes. But I think you agree that too much is not helping, because then you have a lot of microcondensation, and you will have a very long aeration time, a lot of tail left from the treatment,
yes.
right?
Yes, I agree. Yes, and because with the chemical indicator tape, you can see when is the ideal result achieved. Sometimes the case can be that we have been planning a longer treatment for that facility, but we can see during the process that the chemical indicators have changed the color ideally, and when we add a bit more time, we can be sure that there is a very clean facility then.
How often you actually, or how often customers require validation with biological indicators?
With biological indicators, not that often. When we look for the customers, of course, when they are in the healthcare sector, then they can want the biological indicator validation. But the chemical indicator validation is enough for the process.
Yeah, I mean, it's been pretty solid. So just for audience information, the typical biological indicators, they are incubated in test tubes, and it takes 5 to 7 days to have a full proof of 6-log decontamination. So it's really a validation process. It doesn't help us in real time decision making. So it's about the experience of the user and the art of understanding what the chemical indicators tell you, or being suspicious if they tell it something too fast or too slow.
Yes.
So what about the situation that you just run the treatment and you can see that the machine is consuming liquid, but the concentration just doesn't raise? What's your conclusion in that kind of situation?
My conclusion in that situation would be that there can be some materials that are absorbing the hydrogen peroxide from the air, or there can be some gaps. But with that situation, we have the detector, the self-protective detectors that we use, so that we can be sure there isn't any leaking of the hydrogen peroxide. But then there can also be some situation with the parameters of relative saturation and relative humidity, which is affecting to the decontamination process.
So how long in and out? So you offload the equipment from your car to the time that you can say bye for the staff. How long does it normally take you?
If we have let's say quite easy target space, one room, it's not very big, and the materials aren't that absorbing, it's around 3 hours.
Including aeration?
Yes. If we have very inert materials there.
Yeah, good.
Yes.
Thanks. So then we have had some other questions or use cases. I don't have pictures of those, but we have been asked about treating aircraft, and there has been a lot of studies on aircraft decontamination, and actually it's quite a standard method, especially in US when there is so-called heavy overhaul or heavy maintenance of passenger and cargo aircraft. And it has been concluded already long ago in very extensive testing that hydrogen peroxide vapor doesn't have any significant effect on any aircraft textiles, for example. Only if you make a condensation into the space, that's when you may have fabrics suffering. But aircraft's structural materials or electronics or any of the sensitive parts, no effect from hydrogen peroxide treatment. So this can be very safely used with aircraft. And of course, in airline industry there are very strict regulations, but nevertheless this method has been used, to my knowledge, since late 90s, or the research reports date to that time. Another very feasible target or feasible use case are ships, cruise liners, yachts, vessels of any type. Because if you have any disease or bacteria outbreak on a ship, that can cause pretty serious consequences. We all know these incidents on the cruise liners even before coronavirus. And on the ships, it's also very easy to isolate an area by just closing the bulkhead doors, and then you can decontaminate even the big cruise liner. You can just go section by section or cabin by cabin, and then declare those areas safe or those areas clean, and move forward. And periodical treatment of certain critical areas like kitchens or lavatories, lounges, that reduces the risk of any infections from other passengers. Of course, it doesn't eliminate it, but it reduces it greatly. And this is also very usable with many logistical solutions. So let's take the discussion to the questions we have. Alexander, I guess we had a bunch of questions coming by email and messaging.
Yeah, you could repeat how long it takes to decontaminate an ambulance, a truck, a bus, and a train wagon, for example.
Okay, so ambulance, based on our own practices, depending on ambient conditions, the vapor treatment phase is anything from 25 minutes to 60 minutes. And the aeration, if the doors can simply be opened and it can be ventilated to outdoor air, and the air conditioning started soon after, it's about 30 minutes, and after that the ambulance is ready and safe to use. Now, somebody may ask, what about the residual microcondensation emitting hydrogen peroxide molecules into air? Well, car, like ambulance, is kind of thankful for the fact that you have a very high capacity of replacement air coming in when the engine is running. So that eliminates the risk of any kind of slow tail part. So that makes cars specifically good use cases. Now on bus, on a normal tourist bus, how many seats they have? 50, 40, something like that. Now bus is a challenging target because you have seats which have fabric surfaces, or they typically have absorbing fabrics. You also have a carpet, you have paddings, you have all sort of textile surface material, so they absorb. So in a case of a bus, I would use two devices, one master unit, one extension unit, networked together. And I don't have any fresh results from a bus treatment, but I would estimate that we would be very close to this 1 hour total time for 6-log kill in a bus. By the way, if somebody in the audience who is in that business wants to have a test run, time and resources permitting, we are willing to do that. Train car, I think same rules apply as to bus. So if we think about the length and dimensioning of a typical Finnish railway system rail car, which is not far from what's elsewhere in the world, I would say that the same dimensioning, 2 units per rail car, maybe 1 hour treatment per car plus ventilation, and the whole train could be done pretty much simultaneously. So like a typical high-speed train here, does it have 6 units? Pendolino trains, I think they have 6 or 8 cars. I think it's 6 cars. Yeah. So technically, if it would be done in a single run, we would use 12 units for the treatment. And the metro train would be pretty much easier because like a Helsinki metro, for example, all the seats are plastic, floors are plastic. There's only plastic and glass pretty much. So it's near inert except the dirt. So the dirt that comes like sand and gravel, that adds up some consumption. But I would say that in a metro train, dimensioning would be 1 device per every starting 200 cubic meters, and that would still ensure quite rapid treatment time. Did I miss one of the targets in the question?
I think it's okay. We could elaborate a bit more in this direction. There are questions about the central heating and central climatization in hospitals and a laboratorium. Should it be better to start cleaning those ventilation locations and heating rooms?
Yeah, that's a very good point. That's a very good question. And yes, in many cases where there's a problem of indoor air, people think that there is mold or some microorganisms. Actually, they quite often come from the ventilation pipes and the HVAC system. So keeping that clean is kind of rule number 1. And for a complete decontamination of a building or laboratory or any facility, I would start from the ventilation system. I would start from first wiping them. There are companies who are specialized in that work. Now, what we have also experimented a little is that we can feed hydrogen peroxide saturated air to the ventilation intake. So that will reduce the amount of microbes in the ventilation pipes. So after the physical cleaning of the pipes, it's relatively simple to make an arrangement where high concentration hydrogen peroxide is actually led into the intakes, and that will clean the pipes. Well, the building should of course be vacated for the purpose, but that would be a good starting point. And when the ventilation system is cleaned, then it makes sense to treat the indoor areas. We had I think it was in the early days of company, we had one big business building or a commercial building in eastern Finland, and they had a big problem with mold and other indoor air microbes, and we treated that with multiple Cleamix machines. And after the treatment, nobody had any symptoms there for more than 2 weeks. The symptoms returned after that time, but the reason was that the building structure was totally contaminated. There was a very heavy mold growth in the structures. So, of course, initially it helped, but because the structure was rotten, once more microbes started spreading again, the problem resumed. So that also proved that what this solution is not for, we cannot heal sick or rotten structures. That needs to be replaced by some other means. But the ventilation system, that really should be cleaned as a first priority and then go about the rest of the building. But with that said, you can also use the ventilation system for distributing the hydrogen peroxide vapor evenly into the building. And of course, this depends a lot on the layout and system specifications, but it's definitely possible.
Thank you. Then there is a question about bigger spaces like 500 cube meters rooms, for example.
Okay, so theoretically, in an inert room, 500 cubic meters wouldn't be a problem, but those kind of conditions never exist. But it's a good benchmark on comparing like a ideal performance. So our recommendation for reasonable treatment times is that we would recommend 1 unit for each starting 200 cubic meters in laboratory-like environment, and 1 unit for each starting 100 cubic meters in office-like environment or like a typical like a meeting room or such. So that's a kind of easy basic dimensioning, and that's dimensioning for reasonable treatment time. For example, at KCDC, we initially started with segmenting where we had about 150 cubic meters per machine, and when we increased that beyond 200, we still had approximately the same treatment time. So that was an example that when you have an inert environment, you can expand the volume that you bring one machine for. But when you have something that consumes, like a meeting room, you have fabrics there, curtains, rugs, carpets, wooden tables, and so forth. So I guess the short answer is that 1 device per starting 100 cubic meters in an office type of environment, and 1 device per starting 200 cubic meters in a laboratory-like environment.
Thank you. And then I have a couple of questions about the danger to people after the treatment. How should we use or ventilate the spaces afterwards?
Another very good question. So depending on the country and regulation type, it's normally recommended that safe level for temporary exposure for humans is between 7 and 10 ppm. Now that ppm means parts per million. And now you can compare that to typical treatment for killing mold. It's about 120, 150. For periodic treatment of hospital room, 250 to 300. And for this mask recycling chamber, we are recommending 600 plus. So for humans, temporary exposure, say like 10 to 15 minutes maximum, 7 to 10 ppm. And for permanent use of the facility or room, it's 1 ppm. So for sustained exposure, for example, hospital room, you can bring in patient only when the sustained concentration is 1 ppm or less.
Thank you. And then there is a question about temperature when you can use this procedure.
Okay, so again, rule of thumb is that the warmer temperature, the better is the efficiency. Now, and low temperatures have the limitation that you have very low condensation point. Now, technically, we can operate at very low temperatures as well, especially when typically low temperature combines with dry air. So we can, technically, we can use the machine from 10 to 15 degrees onwards without big risk. However, it's not very practical, it's not very comfortable. So the recommended temperature is 20 degrees centigrade or more, and I think there is no natural temperature which is too high, but generally I would say that the ideal conditions are about 25 centigrade or a little bit more. The efficiency increases by increasing temperature, but so does the instability of the hydrogen peroxide molecules. So exactly know where the exact sweet spot is. That needs to be further investigated, but in normal environments we don't have real upper limit, but the recommendation is that don't do it in cold room, at least have 15 degrees centigrade or more, preferably 20. Technically, if you are really experienced user, you can do it in any above zero temperature, but then you have severe limitations on what kind of concentrations you can get in whatever is the ambient humidity and other conditions.
Thank you. Then we have a couple of questions about CE marking, and does it meet medical device regulation or medical device directive?
Okay, we have CE, of course, but hydrogen peroxide generator by definition is not a medical device, so it doesn't meet the criteria in that sense. So this is not used for treating patient. For example, surgical knife is a medical device, but hydrogen peroxide generator is not a medical device. Of course, some countries or some end users may require that, and they have full right to do so, but by definition this is not a medical device. We are in process of getting the medical device certification for the reason that some end customers have been requiring that, and we are working on that. But the time being, this is not a medical device certified, and from definition point of view, it doesn't even need to be.
Thank you. And then a question on the logistics. Is it easy to transport, or do we need special car, maybe something like that?
Okay, transporting the device itself is easy. It's a briefcase, you can carry it. So the transport of the device doesn't cause any logistical problem. It weighs 9.5 kilos. However, hydrogen peroxide liquid, you have to follow the safety regulations which are applicable to your country. However, the UN 2014 rulings apply to this. So you can transport it in a van. You can even transport it in a car. You just follow the general guidelines of transport of hydrogen peroxide. The standard 1 liter bottle that this machine is using, I mean 1 liter bottle is enough for a full workday. That doesn't require much space, and it's very easy to put inside some water liquid tight package. Actually, personally, I'm using a kind of picnic cooler to transport few bottles of liquid in car. So if something leaks, it remains in that plastic enclosure. But UN 2014 is the transport regulation rule.
Then we have a comment on mask recycling. How to ensure that there is how to ensure there is no more risk of toxicity for the mask holder after the PHV decontamination?
Okay, so this is a good question, and it relates to why some authorities don't like the idea. There is no absolute proof, so it should be examined in a laboratory. However, how these procedures are defined is that lab testing the scientists doing these testings, they have placed both biological and chemical indicators inside the mask's fabric. So for example, the test we conducted with VTT, we did in a way that the mask was the layers were separated from each other, and we placed indicators inside the mask and then put the layers back together. So we simulated a situation where the virus or bacteria is exactly in the middle of the fabric, and this was repeated multiple times with multiple masks, and also we are now doing testing with biological indicators. So the idea is to confirm what is the time which is sufficient that you can be sure that this, or no, well, you can never be sure, but you can be sufficiently sure that this mask is equal to new one when it comes to safety. So Professor, what do you think about this testing approach that indicators are placed inside the mask fabric and analyzed?
I think it's a little bit difficult to say, but I should say that we are faced with very urgent situations, the COVID pandemic. So in Korea, we have developed, fast track to approve, the government authority approve that the way, how to protect more appropriate in this circumstance, how to fight with that COVID-19 spread out. So I think your guys that the VHP treatment to the even the hospital, even that the vehicle, yeah, it's very the efficient way to the decontaminate of the virus. So you should, if you can, you should ask your authority or your government that the urgent situation you need to fighting weapon, the efficient weapon we need the urgently, then probably temporary permissions or even more the fast track to get the approved to use your test treatment to the protect or decontaminate of mask or even utensils, even that space. I think the VHP is quite good tools to fight with the virus, even the microbacteria, I think.
Thank you. So, do we have anything else there? I guess we had.
Yes, we have.
Yeah.
We have a lot of questions about the commercial side, and I would answer to them all that please contact finprotec.fi, and we will put put our mail address on the material, so you can contact us for that. One question was the availability of this gear. Can you develop it a bit?
Okay, so availability, we are right now shipping out pretty much everything that that comes out of the assembly line. We are increasing capacity. That capacity increase will start taking effect towards end of April, early May. So after that, we should be getting rid of all the backlog in production. So what we have been very happy is that we have gotten inquiries from all over the world. Our website with listed partners is lagging maybe 3 or 4 weeks behind. so we have sorry for all of those who have signed distribution agreements recently. We try to I promised to update it over the Easter holidays. Actually, my webmaster is sitting here next to me, so she probably has a little bit peaceful time during the Easter, so you can update the web. Yeah, so right now we have a little bit backlog, but we are doing our best to get all deliveries in the field on time.
Thank you. There is some questions still pending, but I think we have exceeded our time limit. So my proposal is that we write the answer on the questions we have in our bank.
Yeah, so that's what we're gonna do. So on this presentation slides, once they come online, we will try to cover in writing those questions which we didn't cover here, and as said, any additional information that you need on the solution, just let us know. And the generic technical questions, when you send them to info@cleamix.com, that gives you the basic technical answers. We try to answer as soon as we can. Sometimes there's a little bit backlog, but we try to answer all technical questions in 24 hours. Sorry if some of you have been waiting now and then, but that's just because we try to get everything answered, and we try to also provide you more coverage than just yes and no. But yes, our time is up, and I would like to extend very special thanks to Professor Young again. Thank you very much for joining. It's always a pleasure to have you here, and I know it's very late there. So
a little bit.
So special thanks for that, and send my regards to all of your colleagues. And also thank you. By the way, did we have any other questions from Italy? So after reviewing all this, what we have discussed, do you have any specific question in mind?
Panu, let's say that I started this webinar with a lot of questions to do it, but at the end I would say that without knowing before my question, you answered to all the questions. So everything, it seems very, very clear to me. Thank you.
Okay, so let's then go to the summary and key takeaways, or at least how we see the key takeaways from this seminar. So first of all, the decontamination of disposable medical gear with hydrogen peroxide, international studies have proven that it's feasible, doable, and it's safe. It's FDA approved in US, and it's being approved in many countries. I hope it will be standard practice. Now, with that said, of course, use of common sense is required. So there should be clear guidelines on what kind of material can be recycled and what can't, or how to make the judgment. So masks, it's very easy. It's either visibly dirty or wet, or has some blood or something else. So that one you definitely have to throw away. But if it's something that you just used for a few minutes and you don't need it after that, that should be go into the recyclables. And also all the other materials, ventilator masks, there are these heavier rubber gloves, aprons, coveralls. A lot of money can be saved by recycling them. A lot of waste can be avoided by recycling, and more or less when it's critical shortage of supplies, it's important to consider. So this is one of the things where use of common sense is definitely required. Now the other focus point, I'm too bad we didn't have our medical expert on this panel, but I think it's proven that the spread of coronavirus by airborne transmission and survivability for several days on surfaces and in the ambient air Okay, it can be said that it's not 100% proven, but there is, in my opinion at least, there is enough evidence that the risk is high enough that this should be taken into consideration. So with that said, the fact that people in Asia are using masks, it's actually now more or less proven that it definitely makes sense. It protects not just the user, but it also protects the other people. So let's face the fact. It doesn't look funny. It's necessary. So let's think about it. Now, of course, the problem here in Finland is that you can't buy surgical masks anywhere. I went to pharmacy last week, and they said no, they don't have any. Not even for medical professionals. Totally out of supply. So that's. Mr. Professor, I can send you a box of chocolate if you send me a pack of surgical masks in exchange. Deal?
You know what? The Washington Post, they give some design of mask there on the page of newspaper, because the USA also they the face that the running out of the mask. So currently they use not the medical mask, but the fabric based, cotton based mask with filter. Yeah, it's the disposable filter to protect that the virus invasion. So that we should think about which technology, which material will be that appropriate the weapon to fight with COVID-19, even though that is not the approved one, but still that we should try our best with our materials and our technology. So if you need a mask, then whatever, just using that some underwear, you can cut off and then make some ribbons, and you cover it like this. So anyway, good luck.
Thank you. And I think one of the lessons for all governments is that even though it makes economical sense sometimes to outsource all manufacturing on basic items to faraway countries, but then when you have the urgent need, it just doesn't happen overnight that you can ramp up production of critical things, including medicines, just like that. So it makes a lot of sense to have a sufficient self-sustained production for domestic use, even if it's not always the most economical way. But I think it's not waste of taxpayers' money to maintain capability of starting mass production of medicines, critical protective gear, etc. So of course, like in Finland, we have a National Emergency Agency which is storing high quantities of all kinds of materials, and they actually their issue is of course that how long does this situation go on? So how much of the critical strategic materials are released, and how much is spared for just in case that the problem persists for a long time. Let's hope that this gets contained soon. And in best case, we have a huge surplus of mass production later this year when everybody is producing them. But I think that's the better case than suffering from lack of materials. But next time we should be better prepared. Hopefully we learn the lessons, and hopefully those who are in power understand what it really means to be prepared, and what it means, that what can happen if the global trade gets disrupted by this kind of pandemics. So I thank you very much for all the panelists. I thank you, Emma, for joining here, and thank you for the staff who organized all this. So let's for the conclusion give big hand for Film-like Studio who supported us on making this all possible. Thank you very much. Have a nice day. Stay safe and have a happy Easter.